this video, we're going to look at using a synthesizer to understand the mathematical definition of a function. In algebra, one area of study is a function. A definition you may have heard is a relation between two variables is a function if each input is related to only one output. These variables are just names of quantities, and we say that the inputs are independent and the outputs are dependent. What you get out depends on what you put in. We see functions in all areas of life. How high a ball is in the air depends on how much time after you threw it. How much money in your savings account depends on how much time since your initial deposit. How many bacteria is in a petri dish depends on how much time since the initial population was introduced. Each of the examples that I just listed have equations that relate the variables which stand for the quantities. And each of these are functions because for each input there is only one output. These functions give a predictability to the relationships. If you and I put the same amount of money into the savings account, we know that we will both have the same amount after a year goes by. If this didn't happen, one of us would be upset and the bank would be in trouble. On a synthesizer, there are many functions. The one that we will look at is called the envelope generator. The quantity that is the input for this function is time, and the output is voltage, which is just energy from electricity. Time is independent on the synthesizer, and the amount of voltage depends on how much time it has been since the start of an event. The event that we will use is a trigger from a keyboard. This graph shows you the function that we will be using. The vertical axis of this graph relates to voltage. As we go up each horizontal line on the grid, the voltage increases by 1. At the bottom, it is 0 volts, and the highest value at the peak is just above 5 volts. The horizontal axis relates to time. As we go to the right, each vertical line on the grid increases by 1 second. From the bottom of the graph to the peak, it takes a little more than 2 seconds to reach the highest value. That first part is what is called the attack stage of the envelope. After the attack stage, the function ramps down before leveling off. This is the decay stage. The level that is reached is set by the sustain level, which is set to about half of the maximum voltage, so about 2.5 volts. After holding on this level, the keyboard will be released and the function takes about a half second to return to 0. This last stage is the release stage. On the envelope generator module, you can see that there are knobs to set the values we've just described. The first knob at the top is the attack knob, and I have it set to just about 2 seconds. The second knob is the decay knob, and that is set to about 1 second. The next knob below the decay knob is the release knob. That is set to about 500 milliseconds, or a half second. And then finally below that is the sustain level. Here this is set to halfway, which corresponds to half of the maximum voltage on our graph. This particular synthesizer is almost 50 years old, so these things are just approximate values. And also when we're setting these from a musical standpoint, we're not trying to be exact with times. We're really just doing this by ear to see what sounds good. So let's hear and also see what this function does. With each of these sounds that I will play, you will also be looking at the oscilloscope, which will show you the graph of the same function that we saw before happening in real time along with the sound. So first we're going to use a noise source. If you wonder what that sounds like, here it is. What I just did to help you hear that was turn up a volume knob. But now what I'm going to do is use the function that we've described to turn that up for me. So now I'm just going to press a key on a keyboard to activate the function. So notice we have the attack stage first. After it reaches the peak, the decay stage, and then it sustains at the level as long as I hold this key down, and then the moment I let go, then it's released. Keeping with this noise source, I'm going to turn it back up, but then I'm going to use what's called a filter to change its sound. So again, I've just applied what's called a filter by just turning a knob, but now I want this function to do that turning for me. So again, the attack stage reaches a peak, decays down to the sustain level, and then when I let go, it's released. Both of those sound like they do the same thing, but this one with the filter is a little bit different. It doesn't increase the volume, it changes what we call the timbre of this noise sound. And now finally, let's see what this function does to the pitch of an oscillator. An oscillator is another sound source from the synthesizer. It just produces a note like this. And now I'm going to use this function to change the pitch of that note. Again, the attack stage, then it decays to the sustain level, and then when I let go, it's released. With each of those three examples, the sounds are affected in a different way by that function, depending on what the sound source is, whether it's noise or note from an oscillator, or if we are affecting a filter, which the source is going through, or if we are affecting the volume of the amplifier. When many sound sources are combined with many envelope generator functions, we can create sounds similar to more traditional instruments, and we can also create sounds that are very unique to electronic instruments.